from Sri Jayendra Saraswati Vidyalaya Matriculation High Secondary School, Singanallur. Today we are going to discuss about Lesson 3 Fluids in Class 9. In this video, we shall discuss about fluids, pressure exerted by fluids, that is gases and liquids, then about Pascal's law, density and principle of flotation and sinking, the application of flotation, that is hydrometer and lactometer, and finally we will discuss about buoyancy and Archimedes' principle. Pressure. The force acting per unit area is called as pressure. That is, the thrust on an unit area is pressure. The formula for pressure is equal to force by area. That is, pressure is directly proportional to the applied force and inversely proportional to the area. In the figure 3.1, the area is large and hence the pressure is low in the first bottle, whereas in the second bottle area is small, hence the pressure is high. The SI unit of pressure is Newton per meter square, or it is also called as Pascal, and the symbol is PA. Pressure in fluids. Now let us see about pressure exerted by fluids. Fluids are generally the substances which has the tendency to flow. Here liquids and gases are categorized under fluids. Like solids, fluids also have weight and therefore exert pressure. When filled in a container, the pressure of the fluid is exerted in all directions and at all points of the fluid. Since the molecules of a fluid are in constant rapid motion, particles are likely to move equally in all directions. Therefore, the pressure exerted by the fluid acts on an object from all directions. It is shown in the below diagram. Pressure in fluids is calculated using the formula pressure is equal to total force exerted by the fluid divided by area over which the force is exerted. Pressure due to liquids. The force exerted due to the pressure of a liquid on a body submerged in it and on the walls of the container is always perpendicular to the surface. In the figure 3.3a, we can see the pressure acting on all sides of the vessel. When an air-filled balloon is immersed inside the water in a vessel, it immediately comes up and floats on water. This shows that water or liquid exerts pressure in the upward direction. It is shown in the figure 3.3b. Similarly, liquid pressure acts in lateral sides also. When a bottle having water is pierced on the sides, we can see the water coming out with the speed as shown in the figure 3.3c. This is because liquid exerts lateral pressure on the walls of the container. Now let us see the factors determining the liquid pressure in liquids. Pressure exerted by a liquid at a point is determined by depth h, density of the liquid ρ, which is sometimes expressed as small p, and acceleration due to gravity g. Now we are going to find an expression for pressure. For that, take a tall beaker as shown in the diagram which is filled with liquid so that it forms a liquid column. The area of cross section at the bottom is A, the density of the liquid is P, the height of the liquid column is h. We know that the thrust at the bottom of the column is equal to the weight of the liquid. So, F is equal to m into g. We can get the mass of the liquid by multiplying the volume of the liquid and its density. Hence, mass m is equal to P into V, where V is the volume of the liquid column, which is got by multiplying area of the cross section into height h. So, volume is equal to A into h. Now, this we are going to substitute in the mass equation. So, m is equal to P into A into h. Now, this equation for mass we are going to substitute in the force equation. Hence, force is equal to m into g, which is equal to P into A into h into g. This is the expression for force. Now we are going to find an expression for pressure. We know that pressure is equal to thrust or force divided by area. Already we have got an expression for force as P into A into h into g. That divided by A will give you the pressure. So when you divide by A, the numerator and denominator has A in common. So we have to cancel it. And finally we will get the expression for pressure as H into P into G. So this is the expression for pressure due to a liquid column. This expression shows that pressure in a liquid column is determined by depth, density and acceleration due to gravity. The final expression for pressure does not have the term area in it. Thus, pressure in liquids depends on depth only. So far we had discussed pressure exerted by liquids. Now we are going to see the pressure exerted by gas. So first let us start with atmospheric pressure. Earth is surrounded by a layer of air up to certain height, and this layer of air around the earth is called as atmosphere. Since the air occupies space and has weight, it also exerts pressure. And this pressure which is exerted by the atmosphere is called as atmospheric pressure. The instrument which is used to measure the atmospheric pressure is called as barometer. The first barometer was a mercury barometer which was first designed by an Italian physicist Torricelli. Air gets thinner with increasing altitude. Hence, the atmospheric pressure decreases as we go up in mountains. On the other hand, air gets heavier as we go down below the sea level like mines. Now let us see about Pascal's law. Pascal's law is named after Blaise Pascal, a French mathematician and physicist. The law states that the external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. This principle is applied in various machines used in our daily life like hydraulic press. Pascal's law can be demonstrated with the help of a glass vessel having holes all over its surface, which picture is given below. Fill it with water, push the piston. The water rushes out of the holes in the vessel with the same pressure. The force applied on the piston exerts pressure on water. This pressure is transmitted equally throughout the liquid in all directions. It is shown in the below diagram. This principle is applied in various machines. Now let us see about density. The density of a substance is the mass per unit volume of a given substance. That is, density is equal to mass divided by volume. The SI unit of density is kilogram per meter cube. In CGS, the unit of density is gram per centimeter cube. The symbol for density is rho. It is a Greek alphabet. At times it is represented in P. So density is equal to mass by volume. The unit is kilogram per meter. Density of matter depends on how tightly the atoms and molecules are packed. In gases, the atoms and molecules are loosely packed, hence less dense compared to the solids which are tightly packed and they are more dense. Next, we shall see the concept of floating and sinking. Whether an object will sink or float in a liquid is determined by the density of the object compared to the density of the liquid. If the density of the substance is less than the density of the liquid, it will float. For example, a piece of wood which is less dense than water will float on it. Any substance having more density than water will sink. For example, a stone which has high density will sink into the water. Buoyant force is the upward force exerted by the liquids. This is the difference between floating and sinking. When a buoyant force is greater than the weight of the object floats. When the buoyant force is less than the weight of the object sinks. Now let us see the application of principle of flotation, which is hydrometer. A direct reading instrument used for measuring the density or relative density of a liquid is called hydrometer. Hydrometer is based on the principle of flotation. That is, the weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. Hydrometer consists of a cylindrical stem which has a spherical bulb at its lower end and a narrow tube at its upper end. The lower spherical bulb is partially filled with lead shots or mercury. This helps the hydrometer to float or stand vertically in liquids. The narrow tube has markings so that relative density of a liquid can be read directly. The liquid which is to be tested is poured into the jar first. The hydrometer is gently lowered into the liquid until it floats freely. Now, the reading against the level of the liquid touching the tube gives the relative density of the liquid as shown in the figure. Now, let us see what is a lactometer. One form of hydrometer is a lactometer, an instrument used to check the purity of milk. The lactometer works on the principle of gravity of milk. It consists of a long graduated test tube with a cylindrical bulb with a graduation ranging from 15 at the top to 45 at the bottom. The test tube is filled with air. This air chamber causes the instrument to float. The spherical bulb is filled with mercury to cause the lactometer to sink up to the proper level and to float in an upright position in the milk. Inside the lactometer, there may be a thermometer extending from the bulb up to the upper part of the test tube where the scale is located. The correct lactometer reading is obtained only at the temperature of 60 degrees Fahrenheit. A lactometer measures the cream content of the milk. More the cream, lower the lactometer floats in the milk. The average reading of normal milk is 32. Lactometers are used at milk processing units and dairies. Now let us see about buoyancy. A body experiences an upward force due to the fluid surrounding when it is partially or fully immersed into it. We also know that the pressure is more at the bottom and less at the top of the liquid. This pressure difference in the liquid column causes a force on the object and it pushes the object upwards. This force is called as buoyant force and the whole phenomenon is called as buoyancy. Most buoyant objects are those with a relatively high volume and low density. If the object weighs less than the amount of the water it has displaced, the density is less. Therefore, buoyant force will be more and it will float. Such an object is known as positively buoyant. But if the object weighs more than the amount of water it has displaced, that is, density is more, buoyant force is less and the object will sink. Such object is known as negatively buoyant. Now let us see about Archimedes' principle. The discovery of Archimedes' principle comes with a nice story. The explanation Eureka is attributed to the scholar Archimedes after he had stepped into the bath and noticed that the water level rose, whereupon he suddenly understood that the volume of water displaced must be equal to the volume of the part of his body he had submerged, and after that he formulated the principle which states that a body immersed in a fluid experiences a vertical upward buoyant force equal to the weight of the fluid it displaces. When a body is partially or completely immersed in a liquid at rest, it experiences an upthrust which is equal to the weight of the fluid displaced by it. Due to the upthrust acting on the body, it apparently loses a part of its weight, and the apparent loss of weight is equal to the upthrust. To demonstrate Archimedes' principle, first take an overflowing jar and fill water as shown in the diagram, and place a measuring jar near the opening end. Take an object, find its true weight, which is W1, using a spring balance. Now immerse the object into an overflowing jar. The displaced liquid is collected in the nearby measuring jar. When the object is immersed in water, it suffers apparent loss in weight which is equal to the weight of the liquid displaced. Thus, for an object either partially or completely immersed in a fluid, upthrust is equal to weight of the fluid displaced, which is the same as the apparent loss of weight of the body. Hence, apparent weight of the object is equal to true weight of an object in air minus upthrust, which is the weight of the water displaced. So far in this video, we had discussed about pressure exerted by liquids and gases, Pascal's law, density, principle of flotation and its application hydrometer and lactometer, buoyancy, and finally the Archimedes principle. Thank you.